In this video, I'm going to demonstrate how we can couple EDEM MotionSolve with PM FlexTire in a simple case with a single tire. So I'm taking the single tire from the example files that you can obtain from the Altair marketplace. These example files are from the 2024 version. I'll point out here that I'm using EDEM version 2025 and the MotionView version 2025. So first off, in this folder, bring this into view here, the single tire flex EDEM folder, we have an EDEM model called input. I'm going to drag and drop that into the EDEM deck, and you can see here that we've got a particle bed. It's pre-populated and no tire. So we can now switch over to MotionView and open up the accompanying MotionSolve or MotionView model. Here, what's included is the MDL file that will open up in MotionView. Also, just to quickly point out here the other files that are included in this case. There is the Fila tire model, the TPF file, the FXT file, that's for the PM FlexTire input, the CAD file of the tire itself, this STP file, and we have a road file, RDF file of a 2D cleat that we will leverage, and the OBJ file used for visualization of that same 2D cleat in MotionView. So in MotionView, let's go ahead and open this model up. And you can see in this case that we don't have a tire, but we have this system of joints set up here that will allow for the motion, or that will describe the motion of the tire. And we have this 2D cleat floor profile that the tire will engage with. So the first thing we're going to do, I'm just going to shift this over so we have a little bit bigger view of the model space. In the entity browser, under vehicle tools and components, I'm going to select tire and double click on that. Now within the tire, I'm going to select the hub as this point down here called wheel. I'm also going to set the center at that same point. And for the tire marker, I'm going to hover my cursor over these three dots and select it for the advanced selector. And here, if I select system, you can see that there's a tire marker defined in here. I'm selecting. Likewise for the road marker, I'm going to select the system. Let's just expand this so we can see it, system, and we have the road marker. Hit OK and create. And I'll switch over to the entity editor. I'm just going to expand this so we can see the full name or full file path. So that the tire property file, we're going to update and use the FXT file that comes with this example. So clicking on the folder here, and I'm just going to copy and paste this file path and select all files. Select the FXT, open, and you'll see once the FXT file is open, we have this additional FlexTire section that's added to the entity editor. The road property file, also we need to update this. By default, we have the NTO flat road. That does not align with this 2D cleat. I want to update this RDF file to the 2D cleat that's in that same directory. So again, clicking on that file path and just pointing to the directory that those files are in. I'm going to select the 2D cleat road, open that. The rest of these parameters I'm going to leave as the pre-populated or default values. We can now come down to the output file directory. That's fine by me, the directory that was pre-populated, but if you wanted to change the directory that this is output, you can modify that here. The handling tire file, the sample Fila with single contact, that's already pointing to the file that's in the output directory, so we don't need to update that. I'm going to click on generate files, and here we've got this added pop-up window, and we will make sure that we're pointing to the step file in the example files. Here it is the MTR 325X 125R 165 step that's already been input in there. Otherwise, would select the CAD file there. The output directory by default is fine. We do need to point to the PM FlexTire converter. And in my case, I've already placed the STP to OBJ in the 2025 version of the EDEM install in bin. So you can see I've got the file path C program files Altair 2025 EDEM and bin. That would be appropriate if you have installed EDEM in the default directory and if you've already obtained the STP to OBJ from the Altair marketplace and placed it in that location. Open that, and you can adjust the fidelity, the resolution, the coarseness of the mesh with this slider. I'm going to update that to 8 or set it to 8, but I'll leave the rim boundary and the belt diameter as the default values of 3 and 90. That should be fine. And I'll hit OK. And what is happening now is that the STP to OBJ command is being executed, passing the tire file that we had provided. And if I bring our output directory back into view, you can see that we have the BDF and OBJ files recently created, along with all of the .off files. So we've got the bead belt inside and sidewall. So that's perfect. That's exactly what we needed. Now the next step will be to transfer this tire over to EDEM. And in order to do that, we'll bring EDEM back up. In the creator, we will enable the coupling server. I'm going to save this before I launch the creation of the tire. And if we go to assembly, select EDEM. And instead of graphics, I'm selecting the arrow beside it, and I will select tires. Likewise, I'm going to select the advanced selector, bring that pop-up window back into view, and you can see that I have a single tire in here that we had just created, selecting that and clicking OK. And then I can go ahead and transfer and create system. So we have this message coming up. Do I want to proceed? Yes. And now within EDEM, we have the tire and the rim that was transferred from MotionView. I will select the rim and set this to have the parent of the tire. In this way, if I expand the tire, in this way the rim will move with the tire. And what MotionSolve is going to do is calculate the dynamics or the movement of this tire. So we want the rim to come along with the tire. I will also point out that for the tire, we already have it pointing to the FlexTire file that was generated from the creation of this subsystem, and the pressure is still set to 0. I'm going to update that to 100,000 to match the FXT file. I will also update the mass of the tire. So if I come back to the FXT file and open this up, you can see that the tire mass was set at 40 kilograms and our nominal air pressure is 100,000. So if I go back to EDEM, I'm going to update the mass to 40 kilograms. I will save that. We've already updated the pressure. Another thing that I will point out in the FXT file is that the air pressure is going to be applied between 0, or the inflation is going to be applied between 0 and 1,000th of a second. It's good practice to use approximately 100 EDEM time steps to inflate the tire. In this case, I save this and go over to the the simulator. You'll see that the time step is already set to 1 e to the minus 5. We're using a Rayleigh time step of something just short of 6%, which is pretty reasonable. but this 1 e to the 5 for the fixed EDEM time step, if we're using this time step, an appropriate 100 time steps would be a thousandth of a second to get the inflation of the tire set appropriately. I'll also point out here that I'll switch over to the GPU solver. I have a GPU on the computer I'm solving, and it will go slightly faster than using CPU. Otherwise, you could leave on CPU and adjust the number of CPUs you're using. So I'll save this, and this simulation is ready to go. Now, in 2025, you may need to save your EDEM deck, close, and open it again to successfully couple it. So I'm just going to go ahead and do this here. I'm going to save it, stop the coupling server, close it, and open it again. So I'll launch EDEM 2025. And in the recent files, open up the input, switch over to the simulator, and enable the coupling server. So EDEM is now ready to proceed with the coupling. If I now come back to the FXT file, a couple other things that I'll point out in here. In this case, we have the sidewall belt, inner liner, and material defined in here in the simplest case, where we're assuming that the behavior of the material is isotropic. You could, if you so chose, define an anisotropic by modifying this input file. But besides that, I think the FXT file is ready to go, and we can now kick off the coupled simulation. If I go back to MotionView, I will save this model before I start the simulation. I'll also point out that when using 2025, you do get this warning or error that no valid EDEM installation was found. You can neglect that. That's an issue that isn't preventing you from running this coupled simulation. And the other messages is just indicating that we've successfully transferred information over to EDEM. One other thing that I should point out that I don't think we have to modify, but is important to realize nonetheless when you're running a coupled simulation, is the communication interval. So if we expand the DEM subsystem that we just created, that was generated by going through the EDEM subsystem creation, you see within the data set that we have a communication interval. That communication interval needs to be an integer of the EDEM time step. Again, the EDEM time step is 1 e to the minus 5. Here we're using a communication interval of 1 e to the minus 3. So there will be 100 EDEM time steps for every communication to MotionSolve, which is reasonable and perhaps on the high end of the communication interval. If you're using a very dynamic system that has high forces coming from the particle geometry interaction, perhaps you may need to use a smaller communication interval, even on the order of 1 EDEM time step to 1 communication interval. And that would be achieved by setting the communication interval to 1 e to the minus 5. Yeah, so this simulation is ready to go. If we go over to Analyze, and here, instead of running it in the preview mode or the live mode, I prefer to run in the offline mode. So by selecting the analysis settings, I'm going to select run offline, and I find that XML seems to be a bit more of a robust solution, and we can proceed with run. And of course, I also have the EDEM simulation deck already set up, and the coupling server was in the listening mode. So you can see the simulation is progressing here. Let me just bring the console of the coupling into view. Oops. And you can see here that after it had reached 1 e to the minus 3, the simulation appeared to increase in speed. That's because during that inflation period where the pneumatic pressure is being resolved on the tire, the PM FlexTire is resolving the normals, the direction of the normals of all of the elements at each EDEM time step. After that inflation period has passed, then the normals are only being recalculated by the user specified file in the text input file, the FXT file, and normally that's on the order of perhaps 1 e to the minus 3 seconds, or at every kilohertz. So this simulation will continue to run to 3 seconds, and this has been a demonstration on how to run a coupled EDEM MotionSolve simulation with PM FlexTire.